Hi everybody, welcome back to Unit 2. Almost done with the videos in this unit. This will probably be the second to last video. So this is lesson 9. It will be due for Wednesday, which is tomorrow. And we're going to talk about why on earth the atomic mass that's reported in the reference tables is actually a decimal number. Because it really doesn't make sense. If you think of a proton is a mass of 1 and a neutron is a mass of 1, when you put those together to get the mass of the atom, it should be a whole number. And yet it's not in our reference table. So the question is why? And usually the guesses are things like, well, they included the electrons. No, they didn't, because those are so small it wouldn't even be reported to the proper number of places that are reported on the periodic table. It wouldn't even show up. Another guess is, well, maybe the mass isn't exactly 1. And that's also correct. It isn't exactly 1, but again, that's not the right answer. That's not why it's a decimal point. Because that still would not be represented on the table. It isn't exactly 1, but it's 1.0000000 something something. So that would not be reported on the table. So the question is, why on earth is it a decimal? Actually, it's a decimal because it takes into account the isotopes, all the different forms of that element that occur in nature. So the book definition for that is that it's a weighted average of all of an element's naturally occurring isotopes. And I think this bears some explanation. What the heck do we mean by weighted average? And what do we mean by naturally occurring? Well, we can make isotopes in a lab. So we're not talking about the isotopes that are man-made. We're only talking about the isotopes that we can sample and find in nature. So for example, if we examine the carbon that's found naturally, there are 3 different isotopes of carbon. Carbon 12, carbon 13, and carbon 14. Now, if we were to take a straight average of these, 12 plus 13 plus 14, and divide by 3, right? Which is normally how you find an average in general. You just take your numbers, add them up, get some total, and divide by the number of values. 12 plus 13 plus 14, that would give us 39. And if we divide that by our total number of values, 3, we would get 13. But if you look on the periodic table for carbon, that is not the mass that's reported. It is not 13. It is 12.011. Why on earth is that? Because we don't do a straight average. We do a weighted average. Let me explain the difference between a weighted average and a straight average when it comes to your grade in my class. Your grade in my class is based on 4 components: tests and quizzes, homework, labs, notebook. Those 4 components. I do not do a straight average. I do not add up all your scores and divide by however many scores there are. I do a weighted average. So I take your test average and I multiply that by what it's worth, which is 65%. Your homework is worth 10%, your labs are worth 15%, and your notebook's also worth 10%. So let's say you are in my class, you're a student, and your test average for the marking period is a 73. Okay, that's your test average. And your homework average is an 82. And your lab average, let's say you're really lazy and you don't turn your labs in, your lab average is a 43. And your notebook, if you don't turn in labs, chances are you're not real organized and your notebook's kind of messy. So let's say your notebook is a 63. I just made those values up. There's nobody I'm talking about in class, for the record. This does not represent anybody's grade. I do not just add these 4 things up and divide by 4. I take into account the weight that I place on each grade. 65% of your grade comes from your test. So I take your 65%, I convert it to a decimal by dividing by 100, and I multiply it by your test average, which was what, 73? I do the same thing for each component. So your homework average was worth 10. I take 10, convert it to a decimal by dividing by 100, and multiply it by your homework grade, which was an 82. Your labs are worth 15%. I convert that to a decimal by dividing by 100, and I multiply that by your lab average, which is 43, because you really stink at labs. And then I take your notebook, which was 10%. I divide it by 100 to get it to a decimal, and I multiply it by 63. And then I add those values up. So if this is you, this is how your grade would be calculated. 65 divided by 100 is 0.65. I multiply that by 73. And that gives me 47.45. Then 0.1 times 82 gives me 8.2. And 0.15 times 43 gives me 6.45. And 0.1 times 63 gives me 6.3. So if we add up all these values, 47.45 plus 8.2 plus 6.45 plus 6.3, we get this student's average in chemistry to be a 68%. So when you do a weighted average, you take into account the percentages that each grade is worth. When you do a weighted average to find atomic mass, you take into account percent abundance. We have a machine, it's called a mass spectrophotometer. And I know you've heard of these if you've watched like NCIS or CSI. I know Abby on NCIS has a nickname for her spectrophotometer. She calls it Major Mass, right? That machine is capable of analyzing substances and indicating what percentage of all the carbon atoms have a mass of 12, 13, or 14, or whatever element it is we're analyzing. So we can take a sample of hydrogen, we can stick it in a mass spec, and it will tell us the percent abundance of each isotope of hydrogen. So that's data that we can have. Here's some data that you may have pulled out of a mass spec. Say we have this element X. 75% of all the isotopes of element X have a mass of 45. And 25% of all the isotopes of element X have a mass of 47. They want you to calculate the average isotopic mass. In other words, what number would we report in the reference tables for element X? That's what they're asking us to calculate, the average isotopic mass, the average atomic mass, the mass that belongs in the table for that element. Well, again, you don't do a straight average, because if you did a straight average, you'd be 46 and you'd be done. You must take into account the percent abundance. Atomic mass is a weighted average of all of an element's naturally occurring isotopes. So how do we do it? Well, here's the steps up here. Step 1, convert the percent to a decimal by dividing by 100 for each isotope. So for the first isotope, it's 75%. I take it and divide by 100. The second isotope is 25%. I convert it to a decimal by dividing by 100. Okay? Second step, multiply the atomic mass by this number. So the atomic mass that 75% abundance went with was 45. So I'm going to take that and multiply it by 45. And I'm going to do that, the same thing for this isotope. This isotope had a mass of 47. And then step 3, add these values together. Add them together. That's all you need to do, and then you will get your answer, your average isotopic mass, your average atomic mass. So if we do this with our calculators, you take 75 divided by 100, you get 0.75, and that's what you'll be multiplying 45 by. This will give you 0.25, and that's what you'll be multiplying 47 by. So if you multiply 0.75 times 45, you get 33.75. If you multiply 0.25 times 47, you get 11.75. Okay? And if you add those values up, now that's step 3, you get your average atomic mass, 45.5. That is the value that, there is no element X, by the way, it's just an unknown symbol. That is the value that you would find on the table, though, if this were real information for element X. Just a note, you should recognize that the average that you get, your answer, should be somewhere between your values. So when you're getting an average, it has to be higher than the lowest number or smaller than the highest number. And it should be closest to the value that's present in the greatest amount. So since most of the isotopes had a mass of 45, we would expect our average mass to be closest to 45. If you get a number like 4,000 for the answer, you did something wrong, right? The lowest number is 45, the highest number is 47. The values have to be in between that. I'm going to give you one for practice that you can do on a separate sheet of paper. Here it is. This is what you'll turn into me tomorrow. And after our quiz tomorrow, we'll be doing more practice with this. Don't forget, your quiz is on protons, neutrons, and electrons, just like the practice one in class today. So the practice I want you to do is this one. Let's assume, bye William, 90.5% of all neon's isotopes have a mass of 20. And 9.5% have a mass of 21.94. Calculate neon's atomic mass. Okay? So you're going to follow the steps that we just did. They are listed in your notes. Convert the percents to decimals by dividing by 100. Multiply the decimal by the mass of that isotope for each isotope, and then add those together. And that should give you your average isotopic mass. Hopefully you get the right answer. We'll see you tomorrow. Have a great night.